Yes. Hey, welcome back. And yeah, I was just remembering the old times when I was a small boy, and I remember solving a problem called rat in the maze problem. And yeah, and first time I saw it, I was like shocked, like, oh my God, how to solve this and all. And then I learned about recursion, and then I learned about backtracking and all. And then I eventually solved the problem. And I thought today, okay, let's make a video on that also. So the question is like pretty straightforward again. So you will have a grid, and in the grid there will be 2 points, a start point and end point. And then there will be some blockages also in the grid, and you will have a rat which will be placed at the start point, and you have to tell in how many ways can it reach the end point. Yeah, again the description might look like scary, so yeah, consider hash as a okay. Yes, so consider hash as a block, that means you can't go through it, and dot as a path in which okay, let's consider star as a path in which you can move through. So imagine a star. Yes, and again over here, if the rat was kept in 0, 0, then it would have only one path. So go right, 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 and then down, 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 down to reach the end of the maze. Or and imagine if this was also a star. Yeah, that means the rat would have two paths which it could take. It would either go right, 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 down, 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 and like or it would go down, 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 right, 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 right. Yeah, and imagine there is this is imagining that the start point is at 0, 0 and end point is at -1, -1. And yeah, you have to, yeah, in the same way, you have to tell like how many ways it can go. And yeah, again, there are many variations of the question. Either you have to tell the direction, so like it has to take like right, go down, or you have to tell the amount of times, like the length of the array, or the length of the, or not the, what do you tell? The number of paths it can take. For example, in this question, the answer would be two, because there are two examples. And yes, so I thought, yeah, this seems like a fun question to do, and so I thought let's code it up. And yeah, I just have the. I thought let's make it look more visually appealing also. So I have the ASCII Unicode values of rat, a brick, and a white block. Where yeah, rat will represent the rat. Brick will represent the path which you can path which cannot be like which you cannot go through, and white block represent the path which you can travel to. And yeah, so let's begin with it. So let's call it maze. And yeah, let's have some depth in it, which yeah, which there will be a lot of initialization for this. So currently, let's have nothing in it, and as the situation comes, or as water we require comes, we'll just populate it. And yeah, let's have a maze object, and yeah, what you have to do, and let's declare the array. Or yeah, array. This is actually representing the maze. So yeah, I told like we'll use star for a path which we can travel to, and blocks for a path which we cannot travel to. And yeah, initially let's have some small block, and then we'll check out for some bigger blocks. Yes, and in this block it's pretty obvious that you can go right, 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 down, 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 or down, 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 right, 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 right. Yeah. Okay, formatting. Yes, and yeah, in maze let's have a method called solve the maze, and let's have start points, which let's take it to be 0, 0, and let's take it to be the length of ARR, the length of ARR. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5, 5. No, we have 5, 6. 1, 2, 3. Yeah. We have 5, 6. So we have 5, and we have 6, and yeah, it is 4 5 because of zero based indexing. And yeah, if you are like confused about the values, do one thing for I in just what to do, print the I value and the length of error at the position I, and you see it will start from 0 0, and you will have till 5 5. 1 2 3 4 5. Yes, this should be zero based indexing. Don't forget, even I got confused once. Yeah, you see it is 5 4. So we'll go from 0 0 to 5 4. I don't know why I wrote 5 5 4 5. First, you have to take the number of rows, and it is 6 rows, so 5 rows, and then you have to take the number of columns, which is 5 columns, so 4 columns. And yes, bear with me, this is going to be a bit of a long video. And yes, in solve maze, what we'll do, we'll send the maze itself, and then we'll send the start, and then we'll send the end. And yeah, I don't think you require any other things to be sent in maze. And so let's define the solve maze over here. And again, since we're inside the class, you have to have a self, and then you got the maze, and then you got the start, and then you got the end. And self dot maze is equal to, yeah, let's define now. Yeah, you can directly inject it through contact constructor also, but let's make it look more good. Like rather than writing maze everything inside over here, let's make a separate function called call maze. And yeah, so what will our init initial have? So we'll have a maze which is actually empty. Star text which is 0. You don't know the value actually, so let's call it 0 for now. We'll have index also. We have end y also. Yes. Mm, why the telling something is not closed over here? I think it will go as I start typing. And because of maze dot start, maze comma start comment, and start text is actually start at the position 0. Start is actually start at the position 1, and then you have index, which is actually end at the position 0, and you have end y, which is actually end at the position 1. And yes, now you have initialized your maze, and you have initialized all the start and end points. So now first what we'll do is we'll directly go through the backtracking part, and then we'll make it look more appealing. So yeah, and then let's call it solve. We'll call the self.solve method over here. And the solve method is nothing but it is just like what you tell. If you know about Java and functional interfaces, then what it tells you that you'll have only one method inside a functional interface, and it is just like to tell, okay, this should be done by this. So in the same way, rather than directly calling backtracking over here, we will call it inside a method called solve. Again, it will have self over here because it's inside a class, and over here we will call the backtrack. BACK, we are calling the backtracking. Okay, and so how does backtracking work? I hope you know. So you'll begin backtracking where? So from the start text and the start y. From start text comma start y, you have to go to index comma end y. That way you have to go to index comma end y. Index comma end y, and yeah, and then you will have a temporary array to store all the paths calculated. And after you reach the end of the array, what you have to do is you have to like append it to a new array which will contain the actual result. So you can have an variable ARR over here, and you can declare ARR like this. But again, while we have to, if we want to call this somewhere else, then what we have to do is that we have to like pass this also. So rather than doing that, okay, I think I made again a point mistake somewhere over here because backtracking is not defined. That's why it's the definition error. So let's have a self dot. Um, yeah, and we'll have all possible paths which will initially be empty. And as soon as we find a solution, we'll append it to our all possible paths. And let's remove the error over here. And never keep any dummy variables like that. You don't want to break your head against the wall trying to debug why what happened. And if you have dummy variables, then it will make your life much more hard. So again, this will take all these values. So you'll get x comma y comma index comma and y. And you don't want to modify the start text and start by itself. So that's why we are taking the values like this. And then you'll have the temp. Correct. 1, 2, 3, 4, 5, and I have 5 variables. Okay, yeah, correct. And so, what is your like rather than base case, what is the edge case or end case? So, if x becomes equal to, I think it's better to have another two variables called the for holding the length of our grid also. So, let's declare them. Let's call grid x and grid y, and let's assign it over here. Grid x is actually the length of the maze, and grid y is actually the length of the maze at the first index at the position 0. Yes, and if you keep like this, you will have index out of bound error. So let's make it -1 also. This is the actual length. Don't forget about that. Zero-based indexing. So what you have to do, if the x becomes equal to the grid x and y becomes equal to grid y, that means you have actually found a path, and then you have to append that path to the all possible paths. So self dot grid x, if it becomes to self dot grid x and y becomes equal to the self dot grid y, that means you have actually found the path. So what you have to do, self dot all possible paths dot append the temp itself. And yeah, the thing is the temp will be more modified, and so if you directly append temp, and what will happen is that you will get errors further down the line, mainly because since temp is being modified and you are directly appending the temp, the value inside the self dot all possible paths, this temp also will get modified. So rather than doing that, just append the copy, and you can do like this, or yeah, let's make it more verbose. Dot yes, and let's append a copy like this, or is what you have to do, return. So now just again think what you have to do. And, just by thinking only, you will get to know what has to be done. And yeah, did you like guess what you have to do? So again, yeah, let's continue. So what you can do is actually for this example, yeah, I think yeah, like yeah, we'll do two things also. First, we'll consider that you can go only in four directions, north, east, south, west, and then we'll add the condition for going in diagonals also. Yeah, adding the condition for diagonals is actually like really easy. So yeah, first let's define the directions over here. I told right, you'll have a lot of initializations to do. Directions is equal to what? We have four directions initially. And yeah, and so first what you can do? Yes, now correct. So either you can go right, left, up or down. So let's just write that out. You're going right, you're going left, you're going down. Yeah, you're going down, you're going up. Is it correct? So 0, 1 means you're going right, 1, 0 means you're going left, 0, comma -1 means you're going left, 1, comma 0 means you're going down, and 1, -1, comma 0 means you're going up. Yeah, let's just save everything one. and or else what you have to do, you actually have the temp. That means after this loop is finished, that means that you have still not reached your solution. So the path you have currently traveled till now. So what you have to do, path dot temp dot append the x comma y. The it's in other words the current path in which you are on. And then what you have to do now, you have to, yeah, again think, after appending the current path, you have to check in the four directions. So you have to go either left, right, up or down. And so now let's do that. So for x comma, oh, okay, just I have used x comma y. So let's call it I comma j in direction. Oh, okay, not that direction. Yes, self direction. We'll have two variables called dx and dy, which will actually calculate the next path which you have to take. So x plus I will tell the I next x coordinate, and y plus j will tell the next j coordinate. And so what you have to do, again, now think about it. Just like think about what you have to do. So if the next coordinate you want to go, like you can't directly blindly go to that coordinate. First you have to check if it is valid. And yeah, let's make a function for that also. We'll get a x and a y. And yes, if since I'm inside a function, I have to self dot is valid. Since I did not mention self over here, I'm getting the issue. Yes. Now I'll get the recommendation also. Is valid. Yeah. So if the current coordinate, so dx comma dy, if it is valid, only then you can continue to the next iteration. So now let's fill the is valid condition. So only if I think again it's better rather than checking all if or we'll do one thing, we'll check for the true condition and then we'll return the note of it. Yeah, you can do that also. And yeah, see the x coordinate must be less than or equal to 0 and less than or equal to grid x, and y should be less than or equal to 0 and less than or equal to grid y, and just take this path and just make the note of it. Yes, because we still have some other conditions here. So if it is in bounds or self dot maze at the position x at the position y, and look at the x and y position. If it is a hash, that means that it is actually a block and you can't go through it. So if it is a block, that means you cannot go through it. Or yeah, again you have to have I hope you know how backtracking works. You don't want to like, yeah, imagine you're over here and you don't to be like go right, go left, go right, go left, go right, go left. That will just lead to infinite recursion and you obviously don't want that. So we have to have a visited set also. Yes, visited is actually a set. Yeah, see the thing, the issue with me was that when I was learning to code, I thought you have to define everything in the beginning itself, or else you will not know what is to be done. And that's not absolutely true. That's not at all true. Just define variables when you want, rather than defining everything, like thinking to the entire solution from start to end in the beginning itself, and then trying to define everything, because that will lead to a lot of complications. You just do one thing. As you're going, you define the stuff you want to do, and yeah, or if the x comma y exists in the self dot visited, that means yeah, you cannot actually go through it. Yeah, let's check if all the conditions are done once. So it should be in bounds, which is being checked by this part. And then you have to be in, you should not have visited that path, or it should not be a grid. Yeah. If this is true, then return false. Or what to do? Yeah, this can actually be done in only one line also, but yeah, let's keep it a bit verbose so that we can understand what is happening the next time we read. Yeah, and it is valid, then what you have to do? If it is valid, again, on reaching a valid point, you just add it to the visited set, or else again you'll be stuck in an infinite recursive loop. So self dot visited dot add the current point, and then start the backtracking from that point. Then for backtracking, yeah, your x has actually become dx and y has become dy. The index remains the same. Yeah, we actually don't need index and dy over here. I don't know why I did that. Where is the, yeah, there is no need for index and dy because we actually can directly get that value. But you actually need the x and the y value because you are actually going to modify it. Reduct and self dot grid y, and then you have to pass the temp. And after the entire recursion is done, that means that you actually found a path. And after you find a path, you have to check for other paths, right? So directly remove the visited path. And after you remove, what will happen is it will just go and check for all remaining paths. And after you have checked for all remaining paths, what you have to do? Okay, consider you're here. First, what you did, you went over here, and then you went over here, and then you went over here. So now what you have to do, and imagine you reach there. That means that, yeah, let's have one more star over here. No, let's have one more star over here. Yeah, imagine you're here. So first you went down, down, down. After reaching down, 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 what you want to do? You want to check if other path exists, and actually another path exists. You can go right, left, down, right. So after you go here, so what you have to do? You have to remove this from the visited. You have to remove this from the visited. You have to remove this from the visited, and then you have to remove this from the visited, and then add it back to visited and check its other neighbors. So you have to check this and all. So we have to do that. That's why we are actually visited dot remove. Yes, you have to remove that from the path. And again, actually, after you reach here, you don't want to keep on appending on it. In other words, after you reach here, you will break out. But if the by chance if this was hash over here, that means you could not reach this point through here. And after you reach here, what you have to do? You have to pop that value from the temp also. If it is, yeah, consider if it is a star itself. And after reaching this part, you have to go back. And so you are in this part, so you have to pop this value out of temp and then check for this value. So after every recursion is done, temp dot pop. Yes, pop it out of the temp. And by now, I think our array should be filled. And I think it's better we just check it out if we have done any mistake. But till now, so let's have some. And this will just print out array. Tell dot all possible paths. M. And yeah, let's just check it out if we have made any mistake. Okay, and we are getting a line in error in line 45. What have I done over there? Maze, yeah. I think it is finished with expecting self dot maze. Okay, that's interesting. Why? Yeah, just check it out once. What is that? Oh, okay. You got it. Don't make mistakes like this. You can't actually pass the maze object over here. You have to pass the array. And yes, since I modified the backtracking solution over here, I have to modify it somewhere else also. Yeah, there's no need to pass grid X and grid Y over here. And this is actually to be done after the entire backtracking part is done. Okay. Uh, Again, it should be this, I think. Just think, let me check why is it happening like that. It should never go out of bounds. Rather than doing that, let us make it like properly verbose only. If x becomes less than 0 or y becomes less than 0 or x becomes greater than dot uh, grid x and y becomes or y becomes greater than self dot grid y or maze self dot maze position x at the position y if it becomes equal to hashtag character or the x comma y which you want to check already exists in this means you cannot like possibly reject. That means return false or else return true. Okay, I can't. Yes, be showing all the possible paths and that's in some. Yeah, let's just keep it for two paths for now. Um, 0001. Yeah, let's check it out. From 00 you can go to 01, 02, 03, 04, 14, 24, 34, and then 44. And then the other path is why is it ending at 44? It should not actually end at 44 over here. And yeah, 00, 01. Okay, again, it's going to 00 and going back to 01. That means as soon as you start to solve it, where is that? Yes, before starting solve, do one thing. Just add the start text to the visitor itself so that you won't like jump back to start the starting point again and again. So as over here, after going to 01, you don't go back, want to go back to 10. Yes. Yes, now we are getting two paths. I think the paths are repeating. So 00, 01, 02, 03, 04, 14, 24, 34, and a 44. Yes. And what is happening is that since it is actually reaching the path, end path, it is not appending that. So let's just take care of that also. Over here, what we'll do, temp dot append the self dot index and the self dot end y. And after appending the actual path, so we'll just pop the temp value out of all that also, so that we won't have any inconsistencies. And yes, now you are actually getting the entire path you want to traverse. And yeah, looking at like this is yeah, it's okay, but hey, when things can be made good, why settle for okay, okay? So now let's call it print image itself. Yeah, and let's take care of that afterwards. So now let's do a make maze. So def make maze again itself. You don't actually want to take anything in this. And yeah, let's have a good looking maze also. It's not goof, it's good looking maze. Yes. So yes, now from our actual maze, let's make out a good looking maze and let's print it out once after making so that we know it's actually working. So how to make a good looking maze? Yeah, that's why I actually have the SK values of rat, brick, and white. So what we'll do is every hashtag will replace it with a brick, and every star or any other character will replace it with a what do you tell a white block, and at the start text we will put a rat. Yeah, that looks like really good, I think. So for row in range length of self dot maze, for call in length of self dot maze at the position 0. Be careful. You want to always put at the position 0, or you can directly use gridx and index, and no, you can use gridx and grid also. But yeah, let's make it more readable. So you have a temp variable over here to actually hold the current uh, array. This the self dot maze at the position row, at the position column. If it becomes equal to hashtag, so what we will do? Temp dot append. We'll append the block over here. So what is the ASCII value of block? Not ASCII value, it's the Unicode value of block. For a brick, it is this one. So we'll directly append this to it. And yeah, don't forget to enclose it in quotes. Else, what we'll do? Uh, I will append a white block. And what is the value of white block? And after this, what you do? So self dot good looking means dot append the temp value. If you don't do like this, then what will happen is you directly append the values over here. So what will happen is that you will not have a two-dimensional maze. You will directly have one-dimensional maze with straight lines, and you obviously don't want that. After this, now what we'll do, we'll actually take the maze object over here, and for row in range maze, I have for row in range length of maze, for call in range length of maze at the position 0. Yeah, let's print out the print, print out the maze at the position row at the position call with the end value being like that. If, since what Python does is that it will automatically print it next to next, and you don't it will automatically print in the next line, and you don't want that. So we are telling that the ending delimiter is actually not slash n, but it is actually a simple space. And after you finish printing the entire row, just print out the slash n, and to print out slash n, you can directly print. I think yeah, by now it should be done. So and it's not print self dot print means the self dot good looking means. Oh yes, I forgot to remove the test over here because I removed the test method. Uh, okay, yeah, that you might think, okay, why I got shocked once, like thinking why it's not happening. That is mainly because I'm not calling the make mesh method only. So we'll call that in. Yes, after solving, you want to let's call the make mesh method. And yeah, this is actually like really good looking. I think you have the maze, you have the bricks to represent you can't go there, and you have the white block to represent you can go there. And now, yeah, let's go on with printing the rat on each maze. Yeah, this is actually like really good looking, and yeah, it is making me happy. I don't know why. See, the thing is, whenever you do something successfully, you will have that feeling of happiness, and I'm having that extreme form of happiness now. And yeah, since you made the maze, you printed the maze. Now we have to yes, let's remove this for now because you don't want to make maze. Whenever you call make maze, you don't want to print out. Let's call this rat image. We'll have self over here. So now just think about it once. Yeah, I think it's better. And now remember, you have all the possible paths which you can reach from in self dot all possible paths. So what we can do is that directly use that values, and yeah, self dot all possible paths has the values from the beginning to the end. So that makes our lives much more easier. So what we can do, write in image for I in for yeah, let's call it row. No, it's okay. I just think about it once. Let's just print it out, all possible paths. And yeah, after you do make mesh, rat in a mesh, you have to call it over here. And as you see, it is actually in the form of a tuple, a list inside a list. It is a two-dimensional array. That's why I got confused once. I was thinking what I've done. So for path in self dot all possible paths, so you will have. Why did this start? Yes. So what you will have? You will have the x and the y value. So for x comma y in path, let's just print out the x and y to check if we are getting it properly. Let's comment it out. And yes, you see that you're getting properly. And what you have to do, just in these points, you just print the rat. So you have the good looking mesh. So self dot good looking mesh at the position x, at the position y. What you want to do? You want to print the rat. And we have the rat emoji over here. And there is an issue if you do like this because there will be multiple paths. So you don't want to directly mess with the good looking image itself. So what we'll do is we'll have a temp mesh. Actually, the self dot good looking mesh. Array, good looking mesh dot. I think we have to like we can't directly copy over here because I tried it out and whatever I did, even though I just copied, it was actually modifying the actual maze object also. So we have to have the deep copy object, and deep copy is actually present inside a module called copy. So you have to yeah, what normal copy does is that it creates a shallow copy, and you don't want a shallow copy, you want a deep copy. So and you have to do a deep copy. I think it is yes, and the deep copy is actually present inside the copy module. So copy dot deep copy of the self good lookingness. And yeah, over here don't do like this. Now you have the template, and we'll remove the x and y. And yeah, that's all. It's done, I think. So let's print. Let's call the print maze method. That's why I made the print maze method actually take an maze object, maze parameter, or else you don't want to directly print the good looking maze because mainly because of this reason. So print maze, you will take the temp maze and print it out. Let's just take it out once. And hey, look at that. Yeah, now that is looking like really good. Let's go. So let's just print out a slash n to differentiate them. And as you see that, let's make it big and let's see our achievement. Yes, and as you see, it's giving one path and it's giving two paths. Let's go. And yeah, if you made it clear, then give a pat in your back because you actually solved it. And then yeah, I think that's all for it. But hey, wait, I think it's better if you make it look like more appealing also. Like what we'll do is rather than directly printing the end path, so what we do, we'll simulate the rat walking also. And like how can we do that? Okay, yeah, okay. Wow. So what we can do is that uh, we'll print the maze over here itself. So what will happen? As you see, if you print the maze over here, you can see the rat walking. And to yeah, let's have a let's import time also. And what we'll do is after yeah, after doing this part, we'll sleep for I don't know 0.5 seconds. And what will happen? Yes. Okay. Yeah. Yeah. Look at that. Look at that. Look at that. You can actually see the rat walking. My God, that looks so good. Let's go. And yeah, let's make it. Let's tell the number of paths also. So we'll have idx is equal to 1. And for, yeah, let's print path idx and then we'll increment idx by 1 and then we'll print another empty line just to be sure. Yeah, rather than that, let's do like this. Yes. Oh my God, look, that looks so good. You can actually say it, path 2. Yeah, it's telling, okay, this is the second path and the rat will go like this, 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 and let's go. Let's make yeah, I think it's better if you don't make maze we modify the maze too much because since it is checking for all possible paths, even small modifications can lead to you having a very large number of paths. But hey, since we are currently not implemented going diagonally, I totally forgot about that. We can just mess around with the maze and check out some other paths. So what we'll do is we'll add another path from here. So you can yeah, let's do it like this. Yes, now we actually have three paths. So let's just check it out. Whoa, whoa, whoa! Look at it running. That looks so good. Yes, 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 yes. Yeah, that's what you want. And the third path, and there it reaches. Let's go. That was good. That was good. That made me happy. Yeah, now let's make. Yeah, and I told about diagonal traversal, right? So that can be done very easily over here. Just add the diagonal ways also. So you can go either go the down bottom or you can go to the top left, or you can go to the yeah, you can go top left or you can go to top right or left bottom. So yeah, and now let's check it out. Now there should be I think more than six paths. Yeah, that is the second path as expected. Now the third path. Okay, that's unexpected. I think it did not save properly. Yeah, now you can see that it's actually jumping diagonally also. And it's stuck in infinite recursive loop, going through the same path again and again. I don't understand. Yeah, now it's changing the path also. Yeah, see, it is jumping all around. It's going in diagonals also. If you look carefully, I told you right. When you add diagonals, it can actually go through lot of different ways. Yeah, see, it is jumping all possible ways. Rather than a rat, it is becoming like a horse, telling I can jump wherever I want. Diagonal paths won't stop me. And yeah, I think there are a lot of many paths. So let's just stop it for now. And yeah, that was it. It was, I think, a really big video, but I hope it was informative and yeah, it was really fun for me to code also. And I hope you also understood how fun it is to do stuff like this. So yeah, don't sit idle. Keep on doing stuff like this and learn new stuff. And especially this one I felt was like really good. Yeah, that's about it. Learn new stuff always and grind more DSA. I know you can do it. Always don't feel sad and all. Bad things will always happen and you have to learn to cope with it. Yeah, that's about it. Thank you for now. Bye.